I think we are live now. Yeah. So in this stream, we are mainly um I don't know what we have to do to be honest, but I have to edit the stream's name somehow. Okay. So in this in the stream we will okay. I think you can hear me. Yeah. So in this stream we will start with the lead code and um like off camera, I only solved two questions, I think, two or three questions. One question was very easy in the quest, that was do some problem. I think that's the first problem in the lead code that is uploaded, hashtag one problem. But okay, like I solved it off camera. And for the next quest challenge, like we have to complete the quest ASAP so that we can move to the next section, that is code forces, and we will do CP31 playlist as much as we can. My senior gave me the target to start with 1100 and complete till 1600, and then like that's the benchmark to at least have a good, to claim that you have completed some good amount of practice for the poise. Okay, so in this playlist we have completed only 9 levels, and today is 18. Like technically we should have completed 15 levels today. Like I have started from 3rd December, and that's really late, but okay, like we are 6 level behind. And yeah, I completed linked list of camera and one question of festival, that is two sum. And in next 2 hours we like plan to complete this hash quest with two questions remaining and three questions of the qualification. Then we have to solve 5 questions in 2 hours. That is very simple. And then we will try to solve two more um two more steps in this, two more levels in this quest. Then we are on the final stage, that is recursion, graph, and tree. And this is really like the final phase of this. Like if we try, we can do this final phase after 25, after 20. So like from 20 to 25 December, we are on the like final lap of the this journey, this quest, and we can easily complete this target uh, before 25 December. So like this is all, but We need to do this very seriously, and we shouldn't. Like, I will not use ChatGPT as much as possible. Uh, we can, um, okay, so like we can set a time limit. After 30 minutes. Um, yeah, like after 30 minutes, we can take some hints from GPT, but before 30 minutes, we will not touch any AI tool. Okay, and we can take any help from Google search. Maybe like I may need some libraries or maybe some SQL syntax, so like that can be seen. That is not um, allowed in OS as well, but like here I'm just starting my journey, so I'm allowed to see. Like I gave myself the permission to see those, but like after I don't think after 2 months I will require anything like that. But or maybe if I require, that is like we can put some constraint till that time. But as of now, they are planning to complete these two levels till like 7 p.m. Then uh, we will not touch any GPT before 30 minutes into a problem, and we can put a Pomodoro to measure the time if we want. And uh, mm, apart from that, we can do Google searches as much as we want, but not very like dependent on the Google searches to solve the problem. And we will not see the solution directly. Okay. Okay. Like I'm talking to myself, not to the stream, just to clear, just to be clear to me what should I do and what is required to be done in this session. Um, okay. So I'm at my home right now, and my colorful light is broken. वैसे like this one, this colorful lamp. Like there is no charging point here. Like the charging point is broken, and there will be a solder required to fix it. But let's see what we can do after we reach the college. Maybe I can take my help from my friend to fix it, but that is very far away thing. Okay, so we will start with this question, this level. How you solve this problem? This very easy problem. So, um, this is the second thing. That is the second problem. Okay. So yeah, like I have had this problem before, but like I was just thinking of the solution, but like this is a lame problem to be honest, and I don't know, like I have some idea, like we just need to like this is a linked list, and there is another pointer, extra pointer here apart from next. Okay, um, and we just need to replicate it. Okay, using new nodes. We cannot return a head. I tried returning it to see like if it accepts the solution or not, but it doesn't accept it. So okay, um, we need to make a new node, and there is no not head, no start head, right? We are given the pointer to the first node. yeah, like this is, there is a what we can say that constructor here, okay? So we need to use it. So we will use, um, we don't know how to use it. We don't know the syntax yet. Um, yeah, I know some bits, like some blur images are in my mind to solve this, but I'm not confident in that logic yet. Okay, so first we will draft the solution that is in my mind to like a pseudocode kind of thing. We will do a new node thing, new node and value. Okay, then we will like we have a name. Okay, we will give the name of node. Um, okay, this will be new node. I guess this is the great. This is the correct syntax as well. And we will point. We will make a new head. Okay, so we will make a node star new new head that will be equal to x. Okay, then we have made a new node, we have made a new pointer. Okay, now we will do a while loop. Okay, or pointer not equal to null. Okay, and then we will do new node, new node, and its value will be pointer. Okay, we will label this, and with every new value we will, like for this new node, we will do the x next equal to this new node. Okay, so like when do we need to make a two? Do we need to make two nodes before we make another node that will be y equal to new node and value will be next value. Okay, then we will find. Okay. So like, so random can point to any value, right? So we need to make sure that, okay, like this is really confusing right now because how do I, okay, so I need to do a dry run, and this is very um big mistake that I have done, like from my previous year's journey, that I don't do dry run before solving the problem. I just try to solve it using my brain. But let's see how this is going to play. Use a new pen. I bought some new pens, so I'm really excited to use these, to be honest. So this is a purple pen, and purple is my favorite color. Okay, so we have a, let's start with an example. This point to the next, then this might point to this, this might point to this might point to this, these are the random, random, and random, these are the next nodes, and we have value 1, 2, 3, 4. Okay, so like I don't know how much you can see it, but can you see it? Okay, like this is the dry run. We have 4 nodes with 4 random pointers and one next pointer. No, 4 random pointers with 4 next pointer of each node. Okay, so we need to create an exact replica. First thing we have to create the base node, okay, the head node. Okay, so like I will write the pseudocode take it first to like get an idea how we can solve the problem. Then converting it to the code is very easy. Okay, so first we create the first create base node. Okay, then what should we do? We have the base node here. Okay, like the first step is done. Okay, then we can assign the next node. Okay. Okay. One thing we can do is like first we create the normal linked list. Okay, each linked list will have a random pointer, but for each pointer it will be assigned to null. Okay, and we will not assign the random pointer while making the linked list. We just um, um, next pointer assign in make rest nodes, rest of the nodes, and assign assign next pointer of each node. We will travel the original linked list, okay, and we will keep track of each node, like where the random node is pointing, and we will point the random. What we will do? We will point we will point each random pointer to the nodes which contain the exact value that is in the head linked list, original linked list. Okay, so like this might be a bad approach, but um, for the time being, we only have this approach, and this might be the correct approach as well. Like there are only 1,000 nodes, okay? So like we don't need to bother about the time complexity because yeah, we can solve it in this way because the number of nodes are very less. Okay, so firstly I will write the pseudocode. Um, create base node. Okay, second will be assign next pointer random pointer equal to null ही रहेगा and this is by default ठीक है we don't need to do anything about this um then create rest of the nodes with while loop in the we can like while doing this while creating rest of the nodes we can just use the hash map right like to the only thing we can use to reduce the time complexity of assigning the random pointer is to use a hash map. And what do we need to store in that? Do we need to store like the for each of the random um, We will figure it out after this. Like first we need to only make sure this will happen. Assign next point. Okay. Okay. So we will make a node that will be represented as x, new node, and will have the value of head well. Okay. Now we will make another node. And we will make another node that will be y, and we will make a new node, and it will have the value of head dot head next value. Okay. And its next will point to y. Okay. Now we will have to point the y next as well. Okay. Like we don't have to do this after the loop. We can make it. Okay. We can make a pointer of node star type. Node star point. It will point to the head. Make it equal to head as well. And we will do the while loop. While pointer is not equal to null, and pointers is not equal to null as well. Then what we will do? We will make a new node. Okay. This will be y. We will do the pointers next. Pointers next value in it, and we will not do correctly here. Like we are creating a new node. We are doing this. Okay. And we will do x equal to y. Then we will make another node. We will do this. This is the new y, and we do y. Okay. Yeah. Okay. So I think we can do this, and we can make another pointer that we need to return as an answer, right? We can use this. This will point to the x, and if we return x, we should get an linked list, but it doesn't have any return pointer assigned. All return pointers are assigned to null. Okay. So like we don't know how to create a new node using this. Can we figure it out by ourselves? Can we do like this? And goes for this. We made the first node. We assigned a pointer to return. Then we assigned a pointer to traverse this. Okay, we didn't move the pointer. Pointer equal to pointers next. we have all the nodes, but the random variable is assigned to null in all the nodes, right? Okay, so like half work is done. Now we have to use the hash map to what should we do? We need to assign the random pointer of each. How to do it? Hmm. Like we can store the index. We can store the. So like while doing this, we can store we can use the unaltered map equal intent. First is the value, and second is this is its what? M. We will put M. How to do ampersand um so we can show this. Like we stored the address of X for this value. And this like right here we will use this node and store its address right here. Okay, and if the random, like now we assign the pointer to head, then we will do a while loop pointer next pointer is not equal to null, and pointers next is not equal to null. Okay, both are not equal to null, and then what we will do, okay, we will check if the pointers random is not equal to null, that means there is some value. Okay, so we will do m random. How should we use this random of the node? We can make another map. I guess we can work with two maps. First, we'll store the values of the random in first. Like the node values can be from this to this, right? Pointer dot random is not null. That means there is something in the null. Okay. Then we will do what we will do. We will do random value. Okay. And okay, where should we store it? So we'll make another pointer. Mod star p will be equal to x, the first node. Okay, and we got p random equal to m of this. Okay, and if after every this we will do pointer, we will shift the pointer as well as we will shift the p. Okay, and this will work until the pointer is there. So like we don't need to check for p. This should work. There can be a int problem. Yeah, int. I don't know how to int star, right? We can make a int star here. This should work. This might work. Assigning map type ak int. Okay. How do we store the address? Ampersand and stars are used, right? Star is used for dereferencing any index, and ampersand is used to store the to store any address in a unordered in CPP. So the node star here, not okay. Just do this. We can just do this. This might work. Like, why is the pointer, right? We don't need to. Remember reference page type long. End dot. Okay, this is the last error that can come in this question, and I don't know how to solve it. And I even don't know how much time has passed. Mhm. Okay, so we are almost there, but there is something right here. How to fix it? Like, what are we checking? Like we have assigned a pointer on the original linked list, then we are like traversing its linked list, and if the random is not assigned to null, we will use that um when we do when we dereference this random and use the value at that position. We need the pointer random and its value. If the value is not saved on the it should work, bro. It's not pointer, right? We can access the random pointer in that pointer and then we can access the value. This should work. What is wrong with this? Should we use GPT to we are almost there. We made the new nodes. We use the hash map to store the address of the nodes. Then we access. Then we are stuck at the assigning the random pointer. Okay. So if we do three, like if there is one in every node, one node three, can this work? I don't think this works like that. Yeah, like we can do this on like this. Like this should access something. Remove this test case. Okay. Now we should run this. We will not ask for the proper solution from the GPT. There are multiple logics, multiple errors. Okay. Okay, like this was intentional. So like to not include this line was intentional. Wrong key. Value is not unique. Multiple nodes can have the same value. Random data are based on the node's address, not values. Copied nodes, mapping of the original nodes. Are the nodes not unique? Nodes are unique, right? No, not unique. Shit. I didn't figure this out. Figure out, but paid attention to. Okay. So like this was a blunder, real big blunder to use map in this way. And you lose the mapping to the original nodes. never stored the pointer's original nodes in the map. He only stored values. Two different nodes with same values. Wrong random link. Random pointers. Loop logic. It's wrong. You wrote node star p. X is the last node. Last node is y, right? Who is X is the last? Okay, shit. Okay, X is the last node. Bro. When people issue X is end of the copied list. Bro, there are so many errors and low conditions skip last node. Yeah, like I knew it. Okay. Last node is never processed. I just ignored it to just reach up to a solution. Then we will fix the first and the fifth are like known to me. I intentionally skipped those two. Core conceptual mistake. Values uniquely identify a node. This is false. Random pointers to the nodes, not values. Yeah, yeah, this was also wrong. And then present a map instead of nodes. Random pointers break completely. This was intentional. We was wrong. Okay, firstly, save this. This was wrong. Okay, this was intentional. So we'll never mind that. We will not make a current node. Then we will store all the current pointers in the map and we will make new nodes. It will point to the next. It will have the current value. Okay. Current is equal to head. Are they linking on by? Okay. Like we are storing the address here. But why we are making new nodes, right? So while current MP current's next is current connects. MP current next is equal to current next. Okay, correct. We can type the logic with our own hands as well. We don't have to copy the logic, right? We shouldn't do that. Just copy paste it and move to the next problem. If you learned out. Like I've understood the solution and like we should. I'm very lazy to write the code again. So keep typing. You understand the logic, right? What is the logic behind it and everything? Okay. So first, let's checking the head. If head is not equal to null. If head is equal to null, then we will return head. Okay. Then we are making unordered map. And we made a blunder of using a int instead of node star. But this is how we should use this. Okay. Now we will make a current node and we will not make another pointer. We will make a current from now on instead of using a pointer. Pointer is too big of a name. Okay, we will make a current node, then we will do while current. If current is not equal to null, current p of a is equal to a dash. This is the meaning of this line. Okay, and we'll do current equal to current next. Okay, this is how we copy we prepare the map. Then we will do current. We will reset the current. Okay. Okay. What should we do now? We will do while. Now we have to assign the pointers. Just empty. Add. Okay. We will do empty current. I haven't. I didn't see any code right now. Okay. So here, next thing that we need to do here is, yeah, like to assign the pointers. Like we have made new nodes there and map them to connect to the map. Yeah. So what we will do is open current next. We will install this. If the currents next exist, then what we will do? we will assign the MP to current next. Okay, otherwise we will do null. Okay, take some exact step for random. We will access the random variable of the new list, and we will if the random of the current list exists, then we will assign it that random. Okay, otherwise we will assign it to null, and we will do current equal to current next. That's it. This is the whole logic behind this whole, and this should work. I don't think that I've made any errors there. Oh shit. Okay. This page is wrong. This should run, please. Okay. So we have started this problem, and we will do it later. And we will test it again, and complexity is very low, bro. How will the two people solving it? They are making a current. They are doing the while, and they are assigning. Okay, they are assigning it right here. Like new node. That they made a new node. Okay, then they assigned the new node to the current next. The current next is new node. What? This is slightly confusing to think in this way, but all of it is solving in the same way. Yeah, divided by node. Every solution is similar. This is similar to our solution. Okay, there are two types of solution in this, right? Okay, we will just try to process one solution right now instead of jumping to the multiple solution. Or do we need to? Should I first process this solution? Oh, look, more different solution of the game. We will move to the next question. Okay, I thought the next question is also too long. Okay, so this is a hard problem, but a short one. The question is so short at least. So, given an unsorted integer array nums and return the smallest positive integer that is not present in nums. Okay. Just need to. Why is it a hard question? Is it about the complexity? We have a unsorted array, right? We cannot sort it and like traverse to the array, but um we can use a map and we can directly insert the. No, we can't insert the. We can use a set. I think if we use a set of int, and we will do nums dot begin nums dot and now the set has all the values, right? Then what we will do, how should we do it? We can use a hash map here, right? Okay. You can easily use a for loop to insert the syntaxes. But not the point here. We need to think about the complexity because this is very easy to figure it out. It still have the time complexity error, and if it doesn't, still we need to find a simple time complexity solution. Okay, so like we find for this, we will do m of nums I equal to 1. Then like we have stored all of this. Then we will do for loop int I equal to 1 I. We will do a while loop. Um, one if int I equal to 1 if m of I is not equal to 1, then return I. And we can also make it we did not use any extra space as well, bro. Like this question is completely ridiculous. Like this solution is completely shit. And just return 0. Yeah. Like this take the account of O of n complexity, and this also doesn't care about the O of n space because we are using O of n space here, and O of bigger than O of n complexity. Yeah, like time complexity is already exceeding here. Okay. So we need to think about the complexities. If this is a hash map question, so how are we supposed to use of one space complexity? Hash map is a dynamic build. In this map, like we can save an input, but it is going to use it. Like the first thing is by itself. I don't know what about it. What do you think about this, bro? How does it? This is quite a pain to. Now I'm unable to think of any solution of this question. Like, how should I change my mindset? How should I think about this problem to solve it? Like, this is the basic question, basic solution, which is which crosses all the boundaries of complexities. Like, even the space complexity is not satisfied according to the requirement of question. Like, the question is really easy, but to meet these conditions to solve it in these complexities is really hard. Okay, like this means we can use a for loop, right? And this means we can only use constants. So like using the hash map is out of the question. We cannot use it. This can be a hash map question, but I don't think if we have to satisfy this condition, constant of space complexity, we cannot use it. Just we can also save it. So how do we solve it? The question was not the first time. Try to solve it. It should be 161. It doesn't matter, to be honest. 24. How to solve it? Oh, hmm, hmm, how to solve it? Like that we somehow need to store any access presence. Okay, so like we cannot use map. Is there anything else that can be used to store the presence and get it in O of 1 complexity? Instead, we cannot use that. Queue stacks cannot use that. We need to sort it. We cannot sort it on O of n. Is there any sorting technique? Sorting technique to sort in of n. Is there anything? If there is anything, then we can several sorting tools under specific conditions. Counting sort operates and number of elements gauge the range of input values. Predict sort gauge the number of digits. Bucket sort There is no general purpose comparison based on the sorting algorithm, since if you feel that can sort arbitrary data, the best possible way to comparison based sorting, and that takes n log n time. Like we cannot non-comparison based sorting can achieve of time complexity under specific conditions. We don't have specific conditions in this question. Like we cannot do a sort, we cannot use a hash map. Like why it is here in the hash map pro? For this, like we are not like this. I don't think it matters. Huh? Wait, wait, wait. Okay. It's like I went to a shop of my mom to get some rice, I think. Yeah, and some other stuff. And on my way, I thought of the problem, but no. So like we are trying to do this right, and just see if we can. Because here there should not be any TL. TL should be on here, but it's some this file loop is wrong, bro. What am I doing? Okay, so like we compare it with this. If it doesn't, so we will do this. This is just basic reasoning, and like yeah, this will work, but on only on the smaller cases. But once we go to this, if the complexity is of n, right? What the hell? The complexity is of n, okay? Because like this is of n, and then we will do this, and this is like there is no nested loop, okay? So like the complexity is of n that is verified, okay? But there is no, I don't think like this should not. This is this concept of space complex, right? If this answer is no, I am cooked. Okay, that's count as an extra space. This is right. One thing that I did wrong was like, okay, the solution is wrong according to requirement, but time complexity is indeed is of O of n, okay, but the space complexity is not of O of 1, so we do need to find the solution to not this. Like if we have to solve it in O of n, I don't know what should we use. We can just look at the solution. Okay, place nums at its correct position if possible. Check which index is wrong. Right, we entered the size, then we while nums of 1 is 0 is greater than 0, then we will do like if the nums of I is positive, then the nums of I, what the hell? Control C. So like this question is wrong technically, take it. Although it is accepted, but this is wrong. Let's solve this question, but in of n time complexity and time and space complexity. was accepted by Leetcode, but it was wrong technically. Um, Help me to understand how should I use data structure to solve it, solve it in required time complexity. Away it starts giving me emotional support before solving question. This is slightly weird when I don't need any emotional support. I will do this in three crystal layers, three clear layers. So nothing feels magical. Okay. My solution is technically wrong but accepted. Your code this. You store n elements in M. That is of an auxiliary space. But the problem explicitly demands O of n time and O of one's extra space. Leet code accepts this because they often accept non-optimal solution. But in interviewer theory rejected. Okay. Big realization. O of one space does not mean no data structure. It You are allowed to modify the input array. The input and the array itself becomes your data structure. This is the key mindset shift. Okay. Constraint that guides the solution. So it is the size of the array. Observation. The answer is always in the range of 1 to n plus 1. Okay. Numbers are less than equal to 0, useless. Number is greater than n, useless. So we care about this idea. Use array indices as hash map instead of this. Okay. So we use nums index mapping rules. We will use the value x at index x minus 1. So like we can accommodate x values here. So step by step correct open space solution. Clean the useless number. Replace all the numbers that are less than 0 or greater than n with dummy n plus 1. Okay, so we placed n plus 1 here. The array now contains 1 to n or n plus 1. Now mark presence using index for every value x. In array, mark x minus 1 as negative. Okay, so like we will do a for loop. We will make a we will use the first value and store it in x variable. Then if the x is greater than 1 and less than this, we will store it. We will use the x minus 1 index and mark it as ये क्या this the finally comes first is don't understand this part. Why are we marking this negative? We only talk about this. We only talk about this one thing. Marking index. The whole solution of becomes just this. What problem are we trying to solve with this? We want to know is x is present in the array or not. Normally, what you do is click right, but map is not allowed. Okay. So where can we store the information without extra space? Inside the array itself. Okay. Key idea. This is the core. Array indices already exist. Okay. So we decided number x is present. Mark nums this. So y x minus one array 0 and x. Okay. So mapping is this. So how do we mark it? We cannot override 0 and 1. Might destroy info. So we use a safe like make it negative. Okay. Okay. So by so some function is not the input was after clear. We will have this. Okay. Now we process access value I can show the build dumpster equal to negative of x out of this. Okay. If 3 is present, when 3 is present, then we will check for we will do this. Okay. Then um set 3 out of range. Yeah. Step 4. Yes, 0 is present. Okay. Now this one is present. Okay. So like and then we will traverse it and whichever is positive, we will say this is missing. So we will get this. Okay. Bro. Yeah, like this is very nice question to be honest. Solve it and like we clean this, then we solve this. We mark the presence and we find whichever is positive, the first number which is positive, we will return it. Otherwise, we will return n plus. Okay. Oh shit. I have solved it before and still like I haven't able to think of the solution. I solved it using set and I solved it using again set. The only thing I tried using was I ignored the time complexity as that at that time. I just focused on submitting as did this message. This was wrong, bro. Okay, it's fine. At least now I know. Okay, so let's jump to the next question. Like we have only 25 minutes left. Solo complete level, which often has three versions. This might have three versions as well. Yeah, it has three versions. One is the two medium. Okay, let's see. So this is a prefix sum. Okay, so like I know the algorithm prefix sum, but I haven't practiced these type of question exclusively. So like there might be some understanding gaps while coding. Mm, let's see what we can do. Like, there is a cycle going on a road trip. The road trip consists of n plus 1 points at different altitudes. The biker starts its trip on point 0 with altitude equal to 0. Okay, so this is the information. The biker starts at 0 with altitude equal to 0. You are given the integer. Okay, so like this is like this kind of uh, we can say it like a snake path, and the initial point is at altitude 0, and the further points might be at like negative altitude or something like that. You're given an array of gain of length n, where the gain I is the net gain altitude between the point I and I plus 1. So like the altitudes are 0, then the second point is yeah. So like um something like that. If we are given two sums, right? Always the altitude array will be will start from zero, and we will. Yeah, this is very easy question to be honest. Like, yeah, we can solve it very easily. And I will solve this. Okay. So we will make a int max, uh, int answer. We can say it equal to zero. The hash altitude should be like this. Then we will do we will make a vector int of altitude. Okay. Then what we will do? We will do int n equal to, will store the size of this uh, original array, chain array. Then we will do a for loop that will start from v equal to 0. Okay. And we will push the altitude 0 is equal to 0. Okay. Then we will traverse this array. We'll do I plus plus. Okay. Then what we will do is this is the uh, first gain. Okay. So we will do we will make int j equal to 1 0. Okay. Then what we will do, we will do altitude, we will do j plus 1, that will be equal to j plus altitude j. So like 5 plus 0. Okay. Then I will move on 1, and um, j will move on minus 5. Okay. We will do this plus this. Then I will move 5 this. We will do this plus this. Okay. Okay. Then we will do j plus plus. Okay. And what we will do, answer equal to max of max of um, altitude altitude of j comma answer. Okay, we will, like, j is increased, so like altitude j will work fine, and we will return the answer. This should work. This should work. See about this. What is wrong? Okay, we need to do this. I array array we've been doing this will be j plus plus array j. This is fine, I guess. Why is it giving the runtime error? Reference binding to null. There is no out of bound. Like this factor can be increased anywhere. Okay. Like data size is not defined. We will do test first. Like we need to do this as well. Okay. We push to 0. Then we run this. We access the 0th index and we do this. And we, okay. This should work. I don't think we are accessing any out of bound stuff right now. Please work. Okay. Like, of course, the index are not defined. So at this point, the array contains a 0 element and 0 size. Hmm. Okay. I've already submitted. Okay. So we make some division. We have 16 minutes to complete two questions. I don't think I can complete this third question right now, but like we will do another live stream after having met in a uh, around 8. No, make some divisible by 5 by p. So this is a medium problem. So given an array of positive integers, nums, remove the smallest subarray, possibly empty. So we are given an array, okay, of positive integers named as nums, and we have to remove the smallest subarray possible, possibly empty, such that the sum of the remaining array should be divisible by. Okay, we need to remove the smallest subarray. Okay, okay. Remove the length of the smallest subarray that you need to remove, or -1 if it's impossible. Subarray is defined as a contiguous block of elementary number. Like if we have this example, as in general, while thinking of the logic, we have to make our own example because this example are very specific and have specific constraint. So like we cannot think of any edge case. But okay, let's finally start with the first example. So like we need to make it divisible by 6, right? So how can we approach this array? We need to first like we need to length. We need to return the smallest subarray. Okay, so we can start with 3 and like 3 plus 1. This is 4. Huh? Uh, maybe. But okay, sorry, it's fine. Okay, I will think about this question and we will take it from there in the next live stream. Bye bye.